Okay, hello calculus class. Welcome back from spring break, or some of you might be watching this on spring break. It is strange to be teaching in this format, and I know this is rough, and it's rougher on you guys than it is on me. So if there's something I can do to help you through this, let me know. We will get through this, okay? So I'm going to be lecturing here at the board. Before the break, we had finished most of section 3.11, which was on the hyperbolic trig functions. The one thing that we hadn't done was take the derivative of an inverse hyperbolic trig function. So that's what we're going to start with. And I've decided to work out the one that involves cosh inverse of x, because cosh and sech are the only two hyperbolic trig functions that are not invertible. Remember, y equals cosh of x looks something like this hanging cable. It has a low point of 0, 1, okay, and it definitely repeats its value, so it's not invertible. However, we can restrict the domain, and we can basically choose either the right side or the left side. Most people prefer positive numbers to negative numbers, so that's exactly what we'll do. So we'll take a look at y equals cosh of x, where x is bigger than or equal to 0. This is the function that we're going to be taking the inverse of. So if I look at that, I can say the original function that we're starting with is y equals cosh of x, x bigger than or equal to 0. So the inverse function will be x equals cosh of y, where y is bigger than or equal to 0. Okay, so as always with inverse functions, we simply switch the roles of x and y. And now I'm just going to take the derivative with respect to x of both sides. And of course, when I do that, I'm viewing y as a function of x, so this is a function composition, and we'll be using the chain rule and implicit differentiation there. So the derivative of x is just 1. Oh, much better. The derivative of cosh is sinh. Remember, no negative sign there for, well, let's finish this. Sinh of y, and then chain rule times the derivative of the inside part times y prime. Remember our derivative rules. For hyperbolic trig, sinh, cosh, and tanh contain no negative sign in the formulas for their derivative. The three that are defined as reciprocals, cosech, cotanh, and sech, do have a negative sign in their formulas. Oh my goodness, that was crazy. Okay, so now I'm going to say y prime is equal to 1 over sinh of y. But as always, I'd like to try to get this in terms of x. Okay. And unfortunately, y is cosh of x. I'm sorry, my bad. X is, we're working with the inverse function here. So x is cosh of y. So, you ready for this? If that were cosh, this would be a sinh. Oh, I wait all year to say that. Okay, but I'm basically composing a hyperbolic trig function with an inverse hyperbolic trig function, and they don't match. So I'm going to do the same thing that we did with our regular trig, which is I'm going to use an identity. And for hyperbolic trig, the main identity is that cosh squared of y minus sinh squared of y is equal to 1. Remember, that helps to explain why we call this hyperbolic trig. If we set x equal to cosh y and y equal to sinh of something, then this parametrizes the right half of the unit hyperbola. Okay, so I'm going to try to solve for sinh of y. So I'm just going to add that over and subtract over the 1. So cosh squared y minus 1 is equal to sinh squared of y. So the square root of cosh squared y minus 1 is equal to the square root of sinh squared, which is the absolute value of sinh. So I want to be able to evaluate that and see, sinh is going to be either plus or minus this square root, but I'd like to know which one. In order to see that, what I want to do is take a look at the graph of sinh. If you remember, sinh looked kind of like this. Its graph was entirely in quadrants 1 and 3. What that tells me is very informally, sinh of something positive is going to be positive. When I plug in something positive, I get out something positive. And sinh of something negative is going to be something negative. My input's negative, my output's negative. That's true of any graph that's going to be in just quadrants 1 and 3. Okay. So now if we take a look, what we were plugging in was y, okay, and, oh, y has to be bigger than or equal to 0. So I can say, and you do need to provide a justification for this, y is bigger than or equal to 0, so sinh of y is bigger than or equal to 0, and then I can say sinh of y is equal to the square root of cosh squared y minus 1, which is the square root of x squared minus 1. So that y prime, jumping back up here, y prime becomes 1 over sinh y is 1 over the square root of x squared minus 1. You are not responsible for having that formula memorized. I will never, in any of the classes that I teach, give anyone credit for having the derivatives of the inverse hyperbolic trig functions memorized, because really they're just not used that often. And in 3B, you're going to learn some other techniques for integrating, no, 1 minus x squared would be easier. You're going to learn some other techniques for integrating things like that than just memorizing a whole bunch of formulas. So you don't need to have them memorized. You are, however, responsible for being able to do the work that we just did in deriving the formulas for the derivatives. And you should be able to do that for all 6 of the inverse hyperbolic trig functions. Okay, I'll leave the others as an exercise because they really are all just doing this implicit differentiation.